Hello and welcome to another nostalgic math chat. We are rambling about IEB's November 2023 paper 1, and today we're looking at question 5a, which focuses on sequences. Okay, so here we go. Consider the arithmetic, I don't know how to say that word, sequence given 22, 25, 28, 31. Okay, so we're going up by 3 each time. Determine the number of terms in the sequence. Okay, so we know the last number, the last term in the sequence is 262. Okay, so we know that for an arithmetic sequence, the nth term is given by a plus n minus 1 d times d. Okay, so in this case, we don't know what n is. Right, we don't know what n is over there for that term. We do know that a, the first term, is 22, and we know that d, the difference, is 3. We're going up by 3 each time. Okay, so, and we know that the nth term, in this case, the mystery nth term, is 262. Okay, so now we can just solve this equation. So we've got 262 minus 22, if I minus 22 on both sides, and I'm going to say, okay, this is 3 times n minus 1. Okay, so that is 240 is equal to, and you can multiply it out if you want. Alternatively, you can divide both sides by 3. So then we've got 80 is equal to n minus 1, and therefore n is equal to 80 plus 1, which is 81. So therefore the number of terms is 81. There are 81 terms in this sequence. Okay. Next question says, represent the sum of all the terms in the given sequence using sigma notation. Okay, so it's very useful that we now know that there are 81 terms here. Okay, because now we can say the sum of those 81 terms is given by, we're going to count from n is equal to 1 up until 81, and each time we're going to add the nth term, whatever the nth term is. Okay, so let's figure out an expression for the nth term. So that'll be, so right now what I've written here is, this is t1 plus t2 plus t3 and so on until t81. Okay, so now we're going to replace the tn with an actual expression for tn. So that is, again, just to remind ourselves, a plus n minus 1 times d. And we know that a, the first term, is 22, and d, the difference, the constant difference, is 3. So let's simplify that for ourselves a bit. So that'll be 22 plus 3n minus 3. And if we simplify that even further, it will be 19 plus 3n. Right. So what that means is the series of the first 81st terms is going to be 19 plus 3 times 1 plus 19 plus 3 times 2 plus 19 plus 3 times 3, and so it will go until eventually we get to 19 plus 3 times 81. Right, and this you can just sanity check is indeed, 22. This is 19 plus 6, which is 25, right, which is your second term. This is 19 plus 9, which is 28, and that is indeed your third term. And then over here we've got 243 plus 19, which is 262, which is indeed your last term. Okay, right, so sigma notation done and dusted. Last question says, if the pattern continues Determine the smallest number of terms that must be added to the sequence above so that the sum of all the terms will be more than 15,000. Oh, interesting. So if we are to continue beyond 262, what is the smallest number of terms that must be added so that the sum of all the terms will be more than 15,000? Okay, so my feeling here is, okay, let's figure out what the sum of these terms is so that we can see how far we are from 15,000. Then I'm going to consider the pattern that continues. Well, do I really? Okay, so this is one way of doing it. So if we're to continue the pattern, the next one will be 265, the next one will be 268, and then 271. And then we can try to figure out, okay, how far do we need to go in this sequence? So how many of these terms do we need in order to cover the shortfall of this guy from 15,000? So first things first, let's just figure out how far from the goal we are. So we know that it's 81 terms, okay? And, okay, let's just start by stating the formula. So that'll be, we could use this one. Okay, or we could use, probably simpler to use the alternative one, which says we just take the sum of the first term and the last term and times it by n over 2. Since we have the first term and the last term, that's probably the easier one. So I'm going to say, okay, the sum of those 81 terms is going to be 81 over 2 times 22 plus 262. Okay, not in the mood to work that out manually, so let us hand that work to the calculator. Okay, so that gives us 11,502. Okay, so then we could try and figure out for a sequence with A is equal to 265, D is equal to 3, how many terms do I need in order to cover this shortfall? So the shortfall is 15,000 minus 11,502, which will be 3,498. So how many of these terms do I need in order to sum up to 3,498? So that's the one way we could do it. The other way we could do it is to say, okay, if I, looking at this sequence, continue to look at it, at what point will Sn be equal to 15,000, right? And then if the result comes back and says, well, it's when n is equal to 100, then I know that, okay, right now I've got 81 terms, so that means I just need to add 19 more terms and then we're good. So either of those is the same potato, really. I think I'm going to go with the second option, though. Just so we're still explicitly working with one sequence. Okay, so we are saying, I guess it's more accurate to say, okay, for what value of n will Sn become greater than 15,000? Okay, because it's possible that the sum of n terms will never actually be exactly 15,000. So let's look at when does it become more than 15,000, and then we'll reason from there. So we know that, okay, well, we don't know what n is, so we're going to say n over 2. We don't know what the last term is because we don't know how many terms we're adding up to begin with. So we're going to use this formula. So that'll be 2a plus n minus 1d, right? When does that become 15,000? Okay, and again, we know that our a is 22, that's our first term. And we don't know what n is, but we know that our d is 3. Okay, just verify that. Yeah, 22 is our first term, and the common difference, we keep going up by 3. Okay, cool. So now let's try and solve this inequality. So we've got n, oopsie, n over 2 times 44 plus 3n minus 3, right? Trying to figure out when it will be bigger than 15,000. Just going to times both sides by 2 to get rid of this little half. Oopsie. Okay, let's just move it out a bit. So times by 2 over here, times by 2 over there. So we just have n, and 44 minus 3 is 41, plus 3n, and this is now 30,000. So then we have 41n plus 3n squared, and we want to know when that will be greater than 30,000. And of course we now have a quadratic inequality. Okay, so what we want to do is we want to get all our terms on one side, 3n squared plus 41n minus 30,000. I am obviously not going to try and factorize that. Okay, but what we want to do is we want to visualize this expression as a graph. Okay, we know it's a parabola. We know that because that coefficient is positive, it's going to be a concave up parabola, right? So it'll be something like this. So it is greater than 0 over here and over here, right? And in fact, yes, okay, you're right. Sorry, I almost confused myself there. Okay, so this expression is positive, right, over here and over here. Okay, so we want to know what are those values of n, what are those ranges of n. So what is this range of n and what is this range of n? Okay, and in order to do that, we're going to need to find the x-intercepts. In order to do that, we're going to use our quadratic formula. Okay, wow, things are getting intense. So 3n squared plus 41n minus 30,000 equals 0 when n is equal to, so I'm just going to first write out the formula and then I will replace the values. Okay, so b is 41. Okay, and we'll replace that here as well. You really should replace with brackets everywhere you substitute, just as a good habit, but I am pinched for space. Okay, and c is negative 30,000. Okay, and a is again 3. Okay, yeah, I can't avoid my space problems anymore. Let me just shrink as much as I can. Okay, I guess I don't need this anymore. Okay, so let's just punch this into the calculator real quick. So let's start with our plus solution. Square root. Okay, so our first n is 93,39 something something. Okay, or okay, our second solution is negative. Okay, but so this is negative 107 comma da da da, and this is 93 comma da da da. Okay, but we know that n can only be positive. N is the position of a term, so we can't have a term in the negative 107th position, right? So we just say here, but n is greater than 0. So that means we're going to take that first solution, 93,39 something something, right? And we will also just I was about to waffle. So we're saying that, okay, n has to be greater than, so we're talking about this range of n's, right? We don't really care about this one because we don't have n's that are smaller than negative 107 whatever, but we do have n's that are greater than 93,3 whatever. So if n is greater than 93,39 something, right, then firstly this expression is positive, right? And more importantly, this is when Sn will be greater than 15,000. Okay, so that means if we added 94 terms, right, then the sum will be greater than 15,000. If we add 93 terms, the sum will still just be short of 15,000, right? Our n has to be greater than 93,39 whatever, and the first whole number that appears after 93,39 is 94. So therefore n is 94. So when n is 94, okay, Sn is greater than 15,000 for the first time. That's important, right? So for any n after that, it will of course also be greater than 15,000, but what we're interested in is the smallest number of terms to add together in order to get over that 15,000 sum, right? So the question also, it didn't say how many terms do we need to add together. It says how many more terms do we need to add to this sequence in order for the sum to be more than 15,000. And because we know that we've got 81 terms here, right? If we want to get to 94 terms, that means we need to add 13 more terms. Okay, so our final answer is must add 13 more terms. Okay, let's verify with the memo, starting from the very beginning. So our first answer, we got 81, which it agrees with. Our second one, we got, same answer, 3n plus 19 as our expression, adding up from n is equal to 1 until n is equal to 81. And then for our last question, we're told that yes, we need to add 13 terms in order for the sum of the in order for the series to be bigger than 15,000. Awesome.